Hello everyone, welcome back to the channel. In this video, I'll show you how to add multiple floors in Ekahau and properly align the floor maps for accurate multi-floor Wi-Fi design and AP placement. This is an important step, when designing wireless network for multi-story building, as incorrect alignment can lead to inaccurate coverage predictions. So basically, what we are going to cover, first of all, I will let you know how to add multiple floors. So on this floor map, you can see we have ground floor, first floor, second floor. So basically, this one I generated from Ikahu because I cannot use the real floor plan for my YouTube videos because they are client sensitive floor maps. But yeah, I'll let you know. So first thing is, let's say if you guys will have three different floors, ground floor, first floor, second floor from same building. So first of all, you have to click on these three dots. You can say this map option. So here you will get all your floor maps. So what I will do is I will name this floor map as ground floor. So I will use this map for my ground floor. So here I have a rename option. So when I will click rename map, so I will get option to edit this name. So I will just, I just type here ground floor. So this is my ground floor. Now let's move to add a new map. So how to add a new map? Click on this three dots, click on this add map, then you will get option to add another map. So now I added one more map. So you can see here now ground floor and then floor plan for three floors. So I will rename it as well for first floor. This is my first floor. And now for the what we can also do is if you will have two different floors on same map, then in that case, what we can do is we can just click on this map of these three dots and duplicate the map. So now we have a copy map. So along with first floor, we have a first floor copy map. So what we are going to do is we will rename this as well. So now this is second floor. Okay, this part is done. Now in all the maps, we can see the same thing, right? So what we are going to do is we are going to crop and rotate the map. So let's crop it. We'll crop it till here. This one is for ground floor. So let's use this. We have the scalings as well. So let's confirm. So now we have our ground floor. Okay, there is a issue. This one is the first floor map, not the ground floor. So we will just press Control Z. And now we will crop it again. Till here. We leave this as well. Yeah. So this first floor is done. Now let's move to our ground floor. Let's crop this one as well. So this is our ground floor. And perfect. So this is done. Now the thing is, it is showing no scale. Unless and until we will not set up the scale, we will not get to use other features. So let's set the scale from ground to second floor. Okay. So we'll zoom in properly. As we can see, from this angle to this angle, it's 30 meter. So this 30 meter is done. Now let's validate this 40 meter. So this one is now 51, right? As you can see here. But let's check the door accurately. So the doors right now is showing 2 meters, but in real time, it will be 0.9 to 1 meter, 0.8 to 1 meter. So now let's check the scale again, whether this provided scale is correct or not. So this is not the correct scale, which you can see here 30 meters, and this 40 meter is also not correct because this room is not, this room looks like 3 by 3 or 4 by 4. Yeah, it's 6.5 by 6.5, something like that. So yeah, our scaling is done. Now we can use the same scaling for rest of the floor. So from here to here, it's 12.8 meters. So let's go to the first floor. Because in a building, this layouts will never change, the auto parameter section. So let's make it 12.8 and the second floor as well. This one is also 12.8. Now, our scaling is done. That means the next part is to draw area and set a coverage requirement. To do this, go to your project, go to your coverage requirement. Let's add another one. So, wireless with WINA requirement. You can name it whatever you want, like as per your client requirement. So, let's set it up. So, our target is minus 65 dBm for all 2.4, 5, and 6. So to apply all settings, we will click here, apply the same criteria to all bands. Now minus 65 dBm is here. Secondary, we need minus 70 dBm for proper roaming. Territory, we don't need. Signal to noise, we need 55. Data rate is minimum 12. Channel interference 2 is fine at minus 85, but we can also do at minus 80, but yeah, minus 85 is done. RTT, this is done, and packet loss 5%. So we'll make it default and close this. Now let's draw the area first. So from here to here, um, this area is done. Now let's move to the another floor, ground floor. We'll draw area here as well. Now this ground floor is also done. Let's move to the second floor. So on the second floor, we will mark the area properly. Yep. So the total area is 287 meter square. On ground floor, it's 284, and here as well, 283. So kind of the area is same because on the walls it might be slightly here and there. That's why it is showing, but it is within 280 to 285. Yeah, within that limit. So this is fine and accurate. Now the next step is to add buildings because all these three floor plans belongs to one building. So to do this, you can see here a building option. So click on this building, then click on action, new building. Now, what floors we have? Ground floor, first floor, second floor. Add floor map. So basically this first floor we don't need here. We need ground floor here. Okay. So what we are going to do is we will remove this and now we have ground floor and here we will add floor below. And here we will select this first floor map. Now this is done. What it is saying, align floors. Align floors is missing. So let's add the floor plan alignment. Basically here you can see we have a floor alignment option. The floor alignment points are used for 3D network planning only to align the floors properly. Connect each map with the same alignment point. So the same alignment points is let's move to the ground floor and let me hide this area. So we will untick this area and let's move this alignment points properly here. Then this is our point one. Then we will use point two here and point two here. So we have added three alignment points. Three is basically fine. So let's move to the first floor. We will add one, to same place. We have to add our floor plan alignment to the same place on all the floor maps. So first floor and ground floor is done. Now let's move to the second floor. Now this is okay. You can also see here, okay, okay, okay. But what if you will move this, alignment point here? So you can see check scale and alignment points locations because inaccurate alignment point will, not show you correct road designs. So our alignment points are accurately placed to their required positions, and you can see okay, okay, okay to everywhere on all three floors. This is done. Now let's move to the difference. So what is the floor to ceiling height of this particular floor, this second floor? The floor to ceiling height is 3 meters. So we will mention 3 meters. Same for this one. And on ground floor as well, the floor to ceiling height is 3 meters. So we have mentioned the floor to ceiling height. Now, what is the difference between, the base of the floor? So this is the base between ground floor and first floor. So this is 0.5 meter thickness. We can say that. Yeah. So this one is 0.5 thickness. How much, attenuation it absorbs. So this is 40 dBm, let's say, and this ground floor, we can even ignore it, but we can also, add it because below of that ground floor, we don't have anything. In case you will have basement floor, then you have to add this one accurately. Maybe the basement floor is quite high, so you can use very heavy floor or 40 dBm is also fine. But during, the accurate predictive design, you have to measure it when you will be on site, how much attenuation it absorbs. So for this one as well, we will use 40 dBm. Now we'll move to our access point. So let's use the access point placement. On what will happen if we will place a AP. So let's say Aruba 635 we are going to use. So we have placed the AP on the ground floor. Let's see the impact of this AP on the first floor. So on the ground floor, this AP we have placed at 3 meter height ceiling mount, and the ERP power is 12.42 dBm. This ERP I will explain you later. So now the signal strength you can see here, which is right now quite good because I have not marked any walls in this area, only the area and alignment points are there. Now let's see the difference on first floor. So you can see we are getting coverage from that AP on this floor map as well, right? On the first floor. Even our AP was on the ground floor, but it is giving coverage minus 62 dBm, right? On first floor. And it will impact on channel interference. So on 5 gigahertz as well, we have coverage. So in that case, what we are going to do is let's check the buildings. So here, right now we have selected 40, right? What if it is, 60? So on 60, we don't have good coverage. It's quite bad coverage. It comes under bad coverage in minus 73 and minus 79. But this will help you to align the channels and the AP power level. So what if, the floor is 20 dBm? You can see if the floor is 20 dBm attenuations, then we have quite a strong coverage in the area from the ground floor AP. So this is the impact. Do we have any impact on second floor? As of now, no, but let's move to 20. So there is no difference, right? So what now we are going to do is we are going to place one AP on this floor as well. So we have placed one AP here. I have selected this AP. Now let's check the impact on ground floor and second floor. So that AP is impacting on this floor. Even I can delete this one. So still we have impact, right, on the ground floor. And when we will move to the second floor, you can see on second floor as well, we have impact from the first floor AP because the first floor is in the middle And this first floor AP is giving coverage on the ground floor as well, along with this second floor. So we have to align it properly. So let's use this 40 dBm here, 40 dBm here. Now we can also adjust this thickness. So let's say the thickness is 0.7 meters and this one as well 0.7, and this one is 1 meter thickness because below of that we have basement or we have nothing. So yeah, now let's move to our design part. So let's draw the walls quickly. Concrete wall for the auto parameter. So even we can hide this alignment points. Click on view and flow untick this floor alignment points. That's it. Your floor alignment points is working perfectly in the background, but it is not visible on your screen. So now we can mark our walls. So let's start from this area. All these black highlighted are concrete walls. This is a glass wall. This is a glass door. Yeah, so this concrete walls are done. Now let's move to this washroom wall is also a concrete wall. Yep, this staircase also belongs to concrete. Yep, this lift. So for lift, elevator self, we are using elevator selves. So this lift is also marked. Now let's mark the internal walls and glass. So we are using window thick 3D VM to mark this glass walls. This is our glass wall. Yep. So our marking is done. Now let's mark the exclusion area. So this toilets are excluded from our survey scope. Staircase as well is excluded. So we are marking this lift as well. So this one is also done. We have marked and excluded it from our wireless coverage scope. This server room is made with drywall. So let's mark it as a dry. And the door is made with glass. Okay. So now there are a couple of walls is left. So here we have drywall to support this window. And here we have concrete wall. This is a pillar. This one as well is a pillar. Yeah, we have highlighted the pillars properly. Here as well, we have one pillar. So let's highlight it. Yeah, this is cafeteria. So now let's assume how many users we have. So accordingly, we can plan our AP simulations. So you can see 1, 2, 3, 4, 5, 6. In each table, we have 6 users. So 1, 2, 3, 4, 24 users, which means 24 users will have, you know, uh, 48 devices, one laptop and one mobile phone. We are assuming. And some of the users can have, we can say, two laptops or an iPad, or might be there are some TVs, printers, and also let's assume total 80 devices. So let's mark the capacity here. So we will draw one area here, and this one is done. We will go to this area. So we'll name this area, edit this area 4 for open office 24 users. Now we'll add devices. So the users have 60 smartphones. Let's set it up 60 smartphones. And the smartphone sync is normal SLA 2 Mbps. How many phones we have? If 24 users are there, so we can use 30 just to add some buffer. So 30 devices will add laptop now. So let's say we will have some Wi-Fi 6 laptops, 6E. How many? So 24. Let's add 30 just to add some buffer. And for the laptop, we are going to use very high SLA because we don't know what they are going to do. Might be they are going to use, file sharing, video conferencing, and multitasking works. So in that case, right now, I have selected 10 MB per second, but we can select according to the customer requirement and application and their uses. So office area, let's add few more things. So add devices, so generic tablet, let's say UIP phones, we can use 6 and the sync is normal 2 Mbps. Now add device, maybe they will have some TV. So we don't see any TV option, so we will configure the profile. Let's add profile 1, office TV. Office TV is going to use 2.4 and 5 gigahertz, so Wi-Fi 6, 50 megahertz is fine. Offset on 2.4, we can leave it on 5 gigahertz. Let's assume 5 dB. Automatic, and we'll close this. And now we can add office TV. So let's assume they had two TVs, and the sync for these TVs is normal high SLA 4 MB. So this area is done. Now for this cafeteria, I think one AP is fine. We don't need to, simulate for the capacity planning for reception as well. So this, because this is the most important area. Now let's add APs. So we have added one AP here. So this one AP, how much it can cover? So we'll go to this signal strength. So this one AP is covering quite good area on 2.4, on 5 as well, or 6 as well. So let's move to the airtime utilization. So now I can see in airtime utilization on 6 gigahertz, it's 69%, free only 31, right? Why it is showing this? Because right now our APs on 6 gigahertz is 40. So we'll make it 80. Then if we will make it 80, then it's quite good. So now I can see the total is 41%, free 59. So still our 59% airtime is free and the limit is 70%. Here you can see. And we can also see the laptop uses. So let's move to the 5 gigahertz. On 5 gigahertz as well. Right now, the total utilization is 55%. So Let's make it 40 bandwidth. This looks good because the free percentage is 64 and utilization is 36%. Right now, let's move to 2.4. On 2.4, we are going to use 20 megahertz only. So we have added one AP here. Now, since this one AP is covering a lot area and our airtime utilization is also fine. So this is quite good. Later on, we will do the channel planning. So let's add couple more APs for proper coverage. So I can say in this reception area, the coverage is almost good here as well. But this single AP will utilize most of this office environment because already we have 24 users, right? So now what we are going to do is we are going to add couple more of the APs. So we'll just copy and paste. Copy here and one AP here in cafeteria. So in receptions might be some guest or clients will come in the waiting area. So they will need some internet with reception. Also this AP will, give the secondary coverage here. In case this AP will down, this AP can provide some support to this area. Also, this cafeteria AP will also provide some redundancy for this individual AP. So these two APs we have added to provide this cafeteria, provide the coverage in cafeteria, and also support redundancy coverage for this office area. Now, when you will see your airtime utilization, it will show you orange. The total airtime utilization is 41%. But if we will change this AP channel to 44, so you can see the difference. Now, these two APs are sharing the coverage. Also, this AP and this AP are running on same channel. So let's change the channel. So this AP, so for this 50 to 56. Now you can see the coverage is quite good. The total utilization is only 30%, right? And yeah, there might be some noise from the background and from the floor. So it will go till 50%, not 70. So this is quite good design. And now let's move to the first floor. How is the coverage on the first floor from those APs? So let's see. So we'll delete this one. So we have some coverages, the background noises, we can say that. So let's make the design on this floor as well. So the same. Now I am going to mark all the outer parameter as a concrete wall just to make this design, easier. But in real time, you can make this design properly so that client is also happy, The client will see you have worked on the floor maps accurately and properly. You have marked all the glasses, windows, everything on the floor map. But for this demo purpose, I can use this concrete wall. Yep. So this is done. Now let's mark. Since the windows are also 3 dBm and drive walls is also 3 dBm, and it does not matter whether I am using windows or drywall, it will impact the same because the attenuation, if we can see, you know, this thing as a point of attenuation factor. So the Windows wall also absorbing 3 dBm and this drive wall also absorbing 3 dBm right now. So yeah, when we will on site, we can check the accurate measurements. What is the accurate measurement? But right now that is fine. So I'm marking the exclusion zones as well for this left area. Yeah, our exclusion is done. So let's place the APs as well. So this meeting room definitely required one access point inside but we have to place this AP strategically, right? So we are going to use the same AP, but how we are going to do is we are going to mount this AP on this corner as a wall mount, and we will use the power 5 deviant. And here we are going to use 11. Here we are going to use 12. We can also, mark areas for meeting room and also deploy the devices the same way we have deployed the devices on this ground floor. We can mark individual areas, but right now I'm not going to do that. I showed you how to do this. So for each and every area, you can do like this for this meeting room, for this and this manager cabin and this open office. So we have deployed one AP here. Now we have also mounted it on wall, but at what height? The height is 2.5 meter as a wall mount. Now let's check the coverage and antenna of this AP. So its antenna is towards here, but we are going to move this here. So now this looks good. Even for the omnidirectional APs, we can also use this minus 90 degree. So this is also fine, and even 90 degree. Okay. So this is more accurate, and it is giving coverage towards this vertically, not horizontally. So this one is done. Now we can simulate APs for this area as well. So manager cabin and meeting room. So here we are going to place the AP on ceiling. Since this particular meeting room is not that much big, so we can just place a AP here as a ceiling mount, and the power is 8, 14, and 17, so that this AP can also give coverage to this manager cabin properly, because this might be a VIP room. So this AP will also give proper coverage here and here, even in case of having high noise or interference. So accordingly, we will increase the power of this particular AP. So here we are going to place one AP for the users, because we have 8, 8, 8, 24 users, and we know for 24 users, we need at least one AP and some redundancy. So we have some redundancy from this AP, because this meeting room, this all the time we don't have users on this room. So this AP will also give, some redundancy for these users. So we can place this AP a little bit down, because this AP can also give redundancy to this particular area. And this AP can give redundancy to here. And overall, these two APs will also give redundancy to all the areas. And this one is the primary AP. So our design is done for this floor as well. Now let's move to the second floor. So on the second floor as well, we can clearly see a conference room. Now we know the plan. So before doing this, let's mark the walls. So we are going to use this concrete wall for the outer parameters, door and office. Even I have included this door as 3 dB, but in real time we can check and we can mark it properly. What is the exact attenuation of those doors and particular room? When we will do the survey on this site, we will get to know. So this design is done. So here we have open office and 3 offices are here, and storeroom and printer room. So this storeroom is also an exclusion area. So let's mark it exclusion. This is done. Now let's move to this office. So yep, let me check the coverage of this. So since here we have 3 offices and open office along with a printer room, So here we definitely need 2.4 and 5. Right now we don't know what technology this printer is using, but let's you know apply the power instead of 5, 4 dBm on 2.4 for this particular meeting room. Let me decrease the cell size because the actual ERP is 7 dBm. You can see 7.42 dBm. That's why we are using 3. We are using antenna gain as well, the antenna gain. Later on, I will let you know how to calculate this ERP in my next video. But as of now, just assume the actual transmitting power is 7 dBm. The height is 2.4. Here we are going to use 9, and on 6 we will use 10. So yeah, this meeting room, or we can say conference room, is properly covered with this one AP for all the users. Now let's think about this offices. So we are going to place couple of APs here. How we have placed this AP? Let me check. Wall mount. This is fine. What is this AP? Yep, ceiling mount and 8 dBm, 14 and 17. This is the power level of the AP. So this AP will now give redundancy to this conference room. It will also cover this offices because we are placing this AP in the corridor. And along with that, because we have 1 or 2 users in this offices, this individual AP will give redundancy to this open office, even though we don't have multiple users like that much users, we only have 12 users. So what we are going to do is we are going to place the AP strategically. So we are going to place AP wall mount in this area as well, so that users we can avoid the channel interference. So we will just increase a little bit power level, 5 dBm. This one should be 12 and this one should be 14. Yeah. So on 6 gigahertz, if users have latest devices, they can properly use the 6 gigahertz on 5 gigahertz as well. And 2.4 will give some coverage here in case those printers are wireless and using 2.4. And 5, even though the printers are on 5 gigahertz, they will get coverage, a very good coverage, minus 56 range. So this is done. Now it's time to do channel planning. Why channel planning? Because you can see even with 3 APs, we have channel interference. So you can see we are getting coverage from this first 4 AP as well, right? So that's why the to do the channel planning is important. So let's do channel instead of selected my network. In my network, we are going to do the channel planning for all simulated APs. Account for all APs on the project. Yes, no, here. 40 megahertz, 80 megahertz. Let's create it. So now we can see everything is 100% apart from 2.4 gigahertz where we can see 91%. So let's analyze the issues. So we will go to network issue. Now 2.4 is fine. On 5 gigahertz, it's showing first star, which means there is an issue with primary signal strength. Is it? No. So the issue is secondary coverage in this printer room. But this printer room is not that much important. Primary coverage is fine for this printer room. So we don't need secondary coverage. We can ignore it. Here in this a little bit corner area, the secondary is failing, but this is fine because it is in the corridor, not in the main areas. So our redundancy will work properly. So let's move to the ground floor. Do we have any issues? No, we don't have any issues. What about on first floor? So in this area, we have some secondary signal strength issues. Current value is minus 75 dBm. and the limit is -70. So we can resolve this by increasing the TX power, but I don't think so. This area is important because it is in the corner near to the staircase. So we can, as of now, ignore it. But in case our client will say, no, we need a proper coverage here. So in that case, what we can do is we can just move this AP a little bit down so that this secondary issue is resolved. And even we can also see the signal strength coverage. So primary is good. Let's move to the secondary. So as per our requirement, we have secondary everywhere. But since we have placed the APs strategically to avoid interference and noise, so let's keep some distance from the APs, at least 7 meters in the office area. If it is not, we are avoiding 15 meters. So we can have some in secondary issues in this area, but this area is not important. So we can ignore this area and we can keep the APC area only so that this AP can properly cover these users because our main target is to provide the coverage for the users who are sitting on the table. So the design is done. We have what we did on this video. So we have added floor plan alignment. Along with that, we have set it up the proper devices coverage profiles. The same way we can also do for rest of the floors for each and every area. But yeah, you can do that. And right now I'm using this, but in case you guys have some, of floor maps from real projects, you can share it with me. Once I will have some time, I will work on it and I will post it on my YouTube channel. So thank you.